All right, next we're going to learn about the quotient rule for exponents. So when we're dividing exponential numbers with the same base, we keep the base and subtract the exponents. Let's see why that's true. Suppose we have 3 to the 5th over 3 squared. Well, then 3 to the 5th is 3 times 3 times 3 times 3 times 3. There's 5 copies of that because it's to the 5th. And 3 squared, there's 2 copies of that because it's to the 2nd power. Notice that this pair of 3's and this pair of 3's will cancel out because everything is being multiplied and divided. There's no addition and subtraction here. We can do that. 3 times 3 is 9. 3 times 3 is 9. 9 over 9 is 1. 1 times 3 times 3 times 3 is 3 cubed. Now it is true that this equals to 27, but the important thing here is that 3 to the 5th over 3 squared, it's 5 minus 2 to give us that exponent of 3. So when we're thinking about the quotient rule, we need to be careful and remember to subtract the exponents. We're not going to add, we're not going to multiply, we're not going to divide. We're going to subtract the exponents. So the negative exponent rule is tricky for most students. I suggest that you never handle a negative exponent without using one of these two rules. So a to the minus n is equal to 1 over a to the n. Or, if your negative exponent is in the denominator, 1 over a to the n equals a to the n. Let's look at an example or two of that. All right, for negative exponents, 4 to the minus 3. An exponent always gives us an order, right? 3 to the 5th tells us multiply 3 times 3 by itself is 5 times. 3 squared, that 2 gives me an order. That's 3 times 3. Multiply 3 by itself 2 times. This exponent gives me an order also. The negative exponent tells me take the reciprocal. Reciprocal is a fancy math word for 1 over that. So the reciprocal of 2 is 1 over 2. The reciprocal of negative 6 is negative 1 over 6. So the reciprocal here, so 4 to the minus 3, the negative sign says take the reciprocal. When I do that and write it as 1 over 4 to the third, I use up that negative sign. All right, and we know this is equal to 1 over 64, but here I'm just going to leave it as the exponential version. All right, another example, 3 to the minus 2 is 1 over 3 squared. The negative exponent says take the reciprocal. So I do 1 over, I copy down the 3 and the 2, but since I've taken the reciprocal, I've used up the negative, so I do not copy the negative. All right, so let's consider this question. What is x squared over x squared? What is that? X squared over x squared. Or I'm just going to erase a little bit of this so it's not too confusing. We're going to leave our rules up for the moment, in case we want to refer to them later. Well, by the quotient rule, that would be x to the 2 minus 2, or x to the 0. What is x to the 0? Well, let's think about this. X is just a number, right? Let's assume it's not 0, because if it were 0, we couldn't divide by x squared anyway. Because 0 squared would be 0 also. So if it's not 0, then any number over itself is equal to 1. So look at that. 1 equals x to the 0. This is a rule we want to learn. X to the 0 equals 1. We'll call this the 0 power rule. And the rule is any number that's not 0 raised to the 0 power as 1. So assume x is not 0, then x to the 0 is 1. Now this is surprising to many students, especially when you see what this means. For example, 7 to the 0 is 1. 1/3 to the 0 is 1. Negative 1/3 to the 0 is 1. 1,000,003 to the 0 is 1. Even if you have a variable in there, as long as you assume the variable is not 0, minus 6x squared y to the 0 is still 1 as long as we assume x and y are not 0, and usually we will. So note that x to the 0 is 1 is a rule that we will use over and over again. All right, let's look at a couple of examples so we can practice these and see all the situations that usually come up. All right, evaluate. 7 to the 0 plus 2/3 to the minus 4. What is 7 to the 0? 1. What is 2/3 to the minus 4? Since we have the minus sign, it says take the reciprocal. For a fraction, the reciprocal is the flip. So this would be 3/2. Now is it to the plus 4 or the minus 4? I know you said to the plus 4 because when we do the flip, when we take the reciprocal, we use up the minus sign. So this is 1 plus 3 to the 4th over 2 to the 4th. Or 1 plus 3 to the 4th is 81. And 2 to the 4th is 2 times 2 times 2 times 2 is 16. 1 can be written as 16 over 16, thus giving us a common denominator. One too many equal signs there. Let's try a plus, which gives us 97 over 16. Right? And if we transfer this into a mixed numeral, we can divide the 16 into 97. And if we do that, we will get 6 and 1/16. Let's check and see that that's true. 16 times 6, well, you might not know that one on the top, off the top of your head, so let's just multiply it out. 6 times 6 is 36. Carry your 3. 1 times 6 is 3. Is 6 plus 3 is 9. 96 plus 1 is 97. So we can see that that must be right. All right, so when we evaluate this, notice that we get a very surprising answer. When we see a negative exponent, that doesn't mean we're going to get a negative number. Sometimes we get a negative, sometimes we get a positive. That negative exponent just says, Holly, take the reciprocal. Right now, take the reciprocal. Do not pass go, do not collect $200. All right, let's look at another example. We can get rid of this one. Evaluate. 9 to the negative 1 plus 3 to the minus 2. Okay, the negative 1 tells me, yeah, that's right, take the reciprocal. So I get 1 over 9, and 3 to the negative 2. The negative tells me, take the reciprocal, plus 1 over 3 squared. Notice that when we take the reciprocal, we do not copy the minus over because we have used it up when we took the reciprocal. If you don't do this, then you'll do this, and then you'll take the reciprocal of that, then you'll take the reciprocal again, and you'll be doing that all day. So remember, when you do take the reciprocal, you have used up your negative exponent, and you're not going to write it in the next step of the problem. 1/9, and then 1 over 3 squared is another 9th, or 2/9, and that is your answer. So when I first saw this, my reaction was, what a stupid way to write 2/9. Why would you write 2/9 this way? The important thing, though, as a math student is that we be savvy enough to understand that when we see this, all it is 2/9. So please practice these until you can simplify them without it being too much of a struggle. There's another example which we use exponents for a lot, and that is scientific notation. There are several different types of scientific notation problems. So the main thing when we have a number in scientific notation the main thing that we want to do is we want to have a number here, and the number has to be, let's call it n. N has to be between 1 and 10. And if you have to choose, it's going to be 1. It has to be a single digit or a digit with decimals after it that's between 1 and 10. It can be 1, but it cannot be 10. And then we multiply that times 10 to a power. So these scientific notation numbers typically look like 6 times 10 to the 7th. Here's our examples. Or 8.345 times 10 to the negative 12. something like this. The really big numbers are used for things like earthquakes, describing the magnitude of an earthquake, national debt, distance of a star, population. The big numbers, the ones with 10 to a positive number, they're used for these kinds of things. The small numbers, like point, this would be point, and there'd be 11 zeros in front of the 8. And then the 3, 4, 5 with the negative 12. These little teeny numbers, these are used for things like science, like if you're doing a chemistry experiment or a physics experiment. Sometimes you do need things accurate to the nearest 8 decimal places or 12 decimal places. It's not unusual. So there are uses for these numbers, and that's why we need to know how to multiply and divide and add and subtract. Well, usually we multiply and divide numbers in scientific notation. So let's look at an easy one. Suppose that we have 3 times 10 cubed times 2 times 10 to the 4th. All we're going to do is multiply number times number, and then we're going to multiply the exponential numbers using the product rule, where we have 10 to the 3 times 10 to the 4 is 10 to the 3 plus 4. So this will give us 6, because 3 times 2 is 6, times 10 to the 3 plus 4, which is 7. And this is the answer. In your textbook and in my math lab, you may see an X here. That's because in typewriting, it's possible to distinguish the times X from the variable X. But writing on the board, it is not possible to do that. So I will always use the dot so that you are not confused. I suggest you do this in your work as well, because many students get to a place where they look at that X and they think, oh, there's a variable, and then poof, a variable appears in their answer when there was no variable in the problem. So I seriously suggest that you use a dot for times in your handwritten work. Let's look at a little bit harder example. So as we have 4 times 10 to the minus 6. And we'd like to multiply that by 2 times 10 to the 3rd. And this might say something like multiply, right? This is something like multiply. It's always good to read the directions. Sometimes you can't figure out what to do without reading them, but it's not 100% of the time. Now, if we have 4 times 2, we get 8. 10 to the minus 6 times 10 cubed is 10 to the minus 6 plus 3, or 8 times 10 to the minus 3. These are 2 easy examples, and the reason they're easy is that we need a number here to be between 1 and 10, including 1 and not including 10. But look, 8 and 6 are between 1 and 10, so we didn't have to work very hard for those. Let's look at another example where we do have to work a little harder. Multiply. All right, now we're going to have 7 times 10 to the 6th times 8 times 10 to the minus 4. 7 times 8 is 56, and then 10 to the 6th times 10 to the minus 4 is 10 to the 6 plus negative 4, or 6 minus 4, which is 10 squared. But this is not in scientific notation because 56 is not between 1 and 10. So we need to write this as 5.6 times 10. Can you see that that equals 56? 5.6 times 10 is 56, and then we just copied down the 10 squared. 10 by itself is like 10 to the 1, so our answer here is 5.6 times 10 to the 1 plus 2, or times 10 to the 3rd. And this is our answer in scientific notation. If you have a problem that has decimals here, like 4.63 or 5.78, please use a calculator to perform the decimal part of the multiplication. But you can still use the simple version to multiply the 10 to the power times the 10 to the power, and that will make your life a little easier if you do that. Remember to check that this number is between 1, could be equal to 1, and 10 can't be equal to 10. And if it isn't, to rewrite it in this way, so that, and then incorporate that 10 with the other powers of 10 so that we can get a good answer in scientific notation.